So we need to show that the given equation holds if cosine inverse of y over b is given by log of x over n raised to the power of n. So let's begin with whatever we are provided. So here we have cosine inverse of y over b. So this is equals to log of x over n raised to the power of n. So this can be also expressed as n times log of x over n. What we have done here is we have used the property of logarithm that states that if we have a multiplied to log of b, that's equivalent to log of b raised to the power of I. Fine. Now what we'll do, we'll take the cosine on both sides. So this gives us y over b equals to cosine of n times log of x over n. Fine. Now let's multiply with b with both sides. Will give us y equals to b cosine of n times log of x over n. So now that we have y, what we'll do, we'll take the derivative on both sides with respect to x. So we have dy over dx on the left hand side, and on the right hand side we have b. B is a constant, so we'll multiply it to derivative with respect to x of cosine of n times log of x over n. Right. Now let's find out this value. Now this will give us b times derivative with respect to x of the cosine function. So this gives us negative sine of n times log of x over n. Now here we'll have to use the chain rule. We'll have to apply the chain rule to the argument of the cosine function. So we'll multiply it to the derivative of n times log of x over n. Fine. Now here n is a constant, so that can be pulled out of the derivative. So this gives us negative b times n times sine of n times log of x over n. Fine. Now we are left with derivative with respect to x of the logarithmic function. The derivative of the logarithmic function is 1 over x over n. So we'll have to again apply the chain rule to x over n. So we'll multiply it to derivative with respect to x of x over n. Fine. So this gives us, so we'll have negative b n squared divided by x multiplies to sine of n times log of x over n multiplied to the derivative of x over n. So this will be equals to 1 over n. So this is the value of dy over dx. So here this n and 1n from both the numerator and the denominator goes away, and this is giving us first derivative of y with respect to x, that's equals to negative b n over x multiplied to sine of n times log of x over n. Now we'll multiply both sides with x. So we'll here get x times derivative of y with respect to x equals to negative b times n times sine of n times log of x over n. Fine. Now what we'll do, we'll square both sides. Squaring both sides gives us x squared times dy over dx whole squared. So this will be equals to b squared times n squared times sine squared of n times log of x over n. Now sine squared of n times log of x over n, this can be also expressed as b squared times n squared multiplied to 1 minus cosine squared of n times log of x over n. So here we have used the identity that cosine squared x plus sine squared x, so that's equals to 1. So we can express sine squared x as 1 minus cosine squared x. The only reason we have done this because we can now replace this value with y. We have already found out the expression for y. So we found out that y is equals to b times cosine of n log of x over n. So that means cosine of, from here we have cosine of n times log of x over n. So this value is equals to y over b. So let's substitute this value. So we will get x squared times dy over dx whole squared. So this will be equals to b squared n squared multiplied to 1 minus. So here we will have y squared divided by b squared. Fine. That means we have b squared times n squared multiplied to b squared minus y squared divided by b squared. So this b squared and b squared gets cancelled out, and we will now have x squared multiplied to, so instead of writing dy over dx, so let us express it in notation form as y1 squared, where we have used the fact that y1, which is the first derivative of y with respect to x. Right. So this will be equals to n squared multiplied to b squared minus y squared. So this is one equation. Now what we'll do, we'll take the derivative on both sides with respect to x. So that means we have derivative with respect to x of x squared times y1 squared, which is equals to n squared multiplied to derivative with respect to x of b squared minus y squared. Right. So here we'll have to use the product rule. We'll take x squared and multiply it to derivative with respect to x of y1 squared plus y1 squared and multiply it to derivative with respect to x of x squared. So this will be equals to n squared times, so the b is a constant, so its derivative will be 0 minus derivative of y squared, so this will give us 2y, but then again we'll have to use the chain rule, so we'll have derivative of y with respect to x. Right. Let's further simplify this. So we have x squared, so derivative of y1 squared will be 2 times y1 multiplied to derivative of y1 with respect to x plus y1 squared multiplied to derivative of x squared will be 2x equals to negative 2n squared y times y1, right, which gives us x squared times 2y1. So derivative of y1 with respect to x, so this gives us the second derivative. We have plus y1 squared times 2x plus, we'll bring the term on the right hand side to the left hand side, so we have 2n squared times y1, so this is equals to 0. Now what we can do, we can take 2y1 as the common factor. Here this will get multiplied to y2 times x squared times y2 plus x times y1 plus n squared times y equals to 0. Now we know that 2 cannot be equals to 0, and y1 that also is not equals to 0, which will be because y is not a constant here. I mean y is not a constant, so that means dy over dx, so that's not equals to 0. So this will be equals, so this is not equals to 0, so this simply implies that we have x squared y2 plus x times y1 plus n squared y, so this is giving us 0, and this is nothing but x squared times second derivative of y with respect to x plus x times the first derivative of y with respect to x plus n squared times y equals to 0. And this is what we were asked to prove. Hence, proof.